Thank you all for getting up early. At least early in Vegas anyway, right? We're going to go ahead and get started. Can everybody hear me all right? My name is Ron Poskevich. I'm the Vice President of Sales and Marketing for Blue Ridge Technologies. We're a manufacturer of BACnet lighting controls. And today I'm going to talk a little bit about the industry in general, talk about distributed controls because there's a trend to go away from the electrical closet and put controls out in the local space. And we'll talk a little bit about that. But before I get started, just by a show of hands in the room, how many manufacturers are in the room? How many owners, facility managers in the room? How many controls contractors? How many electrical folks? A few. Engineers? Okay. All right. Well, we'll get started. I'm not going to spend a lot of time on this. Hopefully you've all read this before. Hopefully what brought you here. So when we look at lighting in general, it is probably the significant load in most buildings, most commercial buildings. This is a DOE chart. Your building might vary a little bit, but in general, the message here is that when you look at where the energy in your building is going, it's going to lighting and HVAC. And most facility folks that I talk to and assist in developing solutions are interested in conquering these two pieces of the puzzle. And in most cases, they're using their building automation system front end as the front end to both of these systems. Some other considerations that I wanted to kind of give to you just to think about is when we look at what are some of the drivers, both I'll call it market drivers and economic factors that are part of the decision-making process that a lot of facility managers and building owners go through, is of course everybody has to meet the state energy code, and if you're not familiar with it, it's basically developed by ASHRAE 90.1. It gets adopted in the International Energy Conservation Code, and then typically becomes part of the state code. There are other states that might go a little further, like California has something called Title 24, but it's essentially a derivative of this, maybe a little bit more advanced. But pretty much every state in the country has some form of an energy code for commercial buildings and residential buildings. And in commercial buildings, it requires some form of automatic off in those spaces. It also requires manual controls and light reduction controls. So that's the minimum code required when you build a new building or do any major renovation work. In addition, some of you might have done a LEED building. Any LEED folks in here? A few of you? Okay. LEED and green globes both are driving more advanced control strategies into buildings. So you're seeing the progression of additional points in rooms, additional control complexity, things along those lines. So we also see those kind of lead to what we call an increase in focus on system performance, both measurement and verification. If you're familiar with LEED, that's one of the credits you can earn related to a LEED building. The other thing we're seeing is also a drive towards unified systems where lighting, HVAC, and security are together. You always hear about the holy grail of lighting controls and energy management and HVAC and security is you come in, you swipe your card access, and all the lights light up all the way to your office, and the temperature is perfect when you walk in the space. But we're seeing the trend in that direction. So some of the economic factors, of course, lighting control is bought because of energy savings. That's the primary factor that most people look at when they're looking at lighting control. Building owners and facility managers that I deal with, most of the time they're asking me, what's it cost me and what's my payback? Those are the two things that are basically driven off of energy savings, whether it's KW or KWH. KW typically comes from you go in and replace the lights and you took that 100-watt fixture and you turn it into an 80-watt fixture. KWH is actually trying to control the hours of operation, and that's where lighting control can come into play. Payback and ROI, many of you might have a payback or ROI window that you're looking for. Most of the folks I deal with are in the less than 4-year range, less than 3-year range typically, unless they're trying to be a little more green or a little more worldly conscious, I guess. They may have a longer payback window, maybe not in all cases, but in certain cases. The other thing that we see out there, another economic factor, is because the systems are getting a little more complex, the control sequences are getting more sophisticated, there is a need for local service and support when you implement these kinds of solutions. So who's going to do this startup? Who's going to do the checkout? Who's going to provide me with training? Who's going to be there when I need help past day one? In a lot of cases, the industry has grown up with what I would call standalone lighting controls, where manufacturer flies in from miles away, does a startup, and he's back on a plane at 5 o'clock going home. And who do you call for support? So those are some of the factors that we see in the industry that are kind of driving something we call unified lighting controls. So when we talk about unified lighting controls, there's some important things I want to kind of give you some differences here. Most everybody out there that might have a lighting control system today in their building probably is over here in this left-hand column, which is what we call standalone, where the systems are completely separate. They have their own front ends, whether that's a centralized relay panel in the closet or distributed controls. There's really no opportunity at this stage to really integrate the two unless you go back to those systems and pay additional money. In a lot of cases, you may also end up with a gateway integration solution. At least in my personal opinion, gateway is good for legacy, bringing in, say, proprietary or older protocols into a new platform or something along those lines. But if you're building the building and you're getting this, there's a lot of consequences from gateways. They add cost, they add complexity. If you're not familiar with a gateway, it typically does a translation between, say, this protocol and that protocol. And somebody has to program that thing. And most of those devices have some sort of point limitation. So once you run into that point limitation, what do you got to do? Add another gateway. So it starts to add cost and complexity. What we're talking about today, and the reason this is possible is because of BACnet, is the ability for us to actually put lighting and HVAC on the same network. In this case, it's BACnet MSTP. That's the predominant solution that we offer, as well as a variety of others. So the benefit of this is that the building automation system that the facilities guys have already paid for, that is controlling their HVAC, can now control their lighting. So your scheduling, your monitoring, your trending, your alarming, your floor plan graphics can all be done through that same user interface. There's no retraining. So any questions on that slide? So the other big benefit you get once you tie lighting control into the building automation system infrastructure, leveraging the open protocol with BACnet, is the building automation system does a lot more than just HVAC typically, or it can. Fire, life safety, security, distributed architecture. I run into a lot of cases where the facility guy goes, well, my electrical guys want access to their system, and HVAC guys or the mechanical guys want access to their system. Well, with a building automation system, that's just a different user profile. So you can say this particular profile, which is the electrical profile, they can see the electrical side of the systems. The mechanical side can see the mechanical side of the systems, but you can leverage the same infrastructure. In addition to that, once you have remote connectivity and VPN access to the building automation system, if you plug the lighting control into that system, that problem is already solved. We don't have to go resolve that problem all over again. The other thing that's you may have heard about it if you're on the West Coast or parts of the eastern seaboard, is demand response. Most of those signals now are coming into a building automation system, whether it's some internet signal or some other mechanism to tell the building automation system, hey, we need to go to a load shed condition. So having that connectivity now is part of the building automation infrastructure. Now the lighting, through just programming changes, could participate in that solution. So a lot of leverage once you tie lighting into that system. The way that that's possible is through BACnet. Hopefully you've attended some other BACnet sessions, and this may be a little repeat, but I figured I'd put it in here for those of you that hadn't. At least in my personal opinion, BACnet is the open standard. It's an ISO standard. It's the only global standard out there right now for building automation controls. As a manufacturer of BACnet products, we made the decision years ago to go BACnet, primarily because we're integrating with building automation companies on a daily basis, and that's the protocol that we saw as the winner in this protocol battle, if you will. The other thing that we like about it is it allows you, as a facility manager or an engineer or a controls contractor, you can actually pick what we call best of breed products. If for some reason I happen to have this best widget and manufacturer B has a different widget that's better than mine, and they're both BACnet, you can use both of our products in that same system architecture. You don't have to always choose my stuff all the time. So it drives customer service. It drives the relationship building with the folks there. The other thing is I see an awful lot of legacy systems out there. One thing that we employ sometimes for customers, they may have a building automation system that's an older proprietary system. That building automation system, it's difficult to go and replace that thing kind of whole hog, if you will, right? But you may have the ability to go into your lighting side of the world, put in a lighting control system in your building, which is in a lot of places around the facility, and put the infrastructure in place, what I call kind of a Trojan horse concept, slap a BACnet building automation system front end on that lighting control, and right now it's just lighting control, but over time now you can extend the tentacles of that system over to the HVAC side of the world and start to pull in the proprietary side or change over the proprietary side to the open protocols. So we think BACnet is a sustainable platform. There's a lot of manufacturers out there offering it. It's going to be around for a long time. There's no proprietary technology. It's owned essentially by the community, not by some manufacturer or provider of parts or anything. If you're a system designer or a controls contractor or even probably a facilities guy, there are some important tools that you need to know about as it relates to BACnet, what we call a PIC statement. That kind of tells you what this particular device can do as it relates to integration with other pieces and systems within the building. And in that PIC statement, typically there's also what we call a BIB list. And if you actually read that, it's hard to say all in one way. So it's basically BIBs for short. But that's essentially the way for you to tell how two pieces of equipment can interact with each other. The other important thing that's not talked about a lot when you look at lighting controls in general, but how we deliver lighting control to the facility is a huge barrier to delivering an integrated or unified solution. In the past, lighting control has been traditionally delivered through Division 16 methodologies by an electrical contractor, and we're asking an electrical contractor to essentially furnish an integrated solution. So you're asking somebody who's not good at a particular core subject to do something they're not good at. What does that do? All right, it's going to inflate that price, especially on bid day, right? Same thing on the mechanical side, right? You have this siloed approach where Division 15, Division 16, things get bid. Nobody knows what they're going to end up with at the end of the day. There's a lot of integration uncertainty that ends up in that process. As a result, when I talk to facility managers or engineers, the general impression that they have before I walk in the door is that integrated controls is more expensive than standalone. And that is always going to be true if you employ traditional specification and delivery methods. That'll never change until you change the behavior of how we deliver that solution to the market. So the way we foster approach is what we call unified controls. We deliver that through a BAS controls contractor, essentially. Somebody who now is responsible for delivering that solution. I'll get into a little more detail here, but when we look at this methodology, it's a value-added reseller model, right? The people that are involved in it are adding value, and they're also eliminating risk in that process. So we believe that alignment is critical to success. If you ask somebody to do something that's outside of their expertise, it's going to add dollars to that equation. So what we said is, look, if we dumped all the pieces on the table, let's ignore tradition and history for a moment. Let's figure out who does what the best. What is the core competency? Well, I'm a manufacturer and I make BACnet stuff pretty darn well. So does a lot of other people, right? Electrical contractor, what are they good at? They're good at making sure that that stuff gets installed, meets the local code requirements, and they don't carry typically laptops to the field. Controls contractor, what do? They understand controls, they understand networking, they understand a lot of different things that are related to control systems, writing control sequences, things along those lines. So when we looked at it, we said, this is the best methodology. We've been using this methodology for over 10 years now. It's delivering results, and it leverages everybody's expertise. There have been some changes in the industry that have allowed this to happen in addition. In the past, the controls contractor was a sub to the mechanical, right? And that's probably still the case in a lot of cases. But if you look at the new CSI formatted specifications, they actually made a change and allowed the controls contractor or the systems integrator or whatever you want to call it to be at a peer level now with the electrical and mechanical. Doesn't mean you still can't do it the old way. It just means that there's an opportunity now to progress in how you specify or how you acquire those products. So the big picture on this is when we look at one system, one user interface, and I say one point of accountability, it's really one throat to choke. That's kind of what I hear a lot. I need somebody who I can hold accountable to deliver that solution. So there's an empowerment going on here, right? If you say, let the controls contractor select the product that works best for that particular application and put it in his number on bid day, right? The electrical contractor knows that he's responsible for furnishing or installing the electrical lighting control piece of this. He knows what his number is on bid day, and there's not a lot of risk in that. And when the job is executed, the controls contractor is responsible for delivering that solution. There's one throat to choke, essentially, at the end of the day. And you're not relying on me as a manufacturer who's hundreds of miles away from you to be your tech support or fly out and support you when you have a problem. So this is kind of a change, but it is key to getting what you're looking for. The other thing I want to do is kind of switch gears now and talk about, okay, now that you've got this system in place and it's unified, what can you do with it? So we're going to go through a few examples of some energy management strategies. This is one I call controlling the bookends. This particular one is showing you essentially the times from basically midnight to midnight. Energy consumption is on the left, and it's relative, 0 to 100%, basically. Your results are vary. This particular one is showing you roughly 1,000 watts. I took a typical classroom, if you will, 1,000 watts, 1,000 square feet. So your energy savings calculation is down here, and I'm not going to spend a whole lot of time going through that calculation, but just to kind of show you where most of the energy savings occurs in facilities is on what I call controlling the bookends. This manual on strategy is to capture some savings in the morning. There are some spaces potentially in your facilities where it doesn't make sense to automatically turn the lights on in advance of people showing up. Now you might do that for egress areas or lobby lights or security areas, stuff like that. But say, hallway lighting or private office lighting or things along those lines, you may just say, let's let the occupants turn them on when they come in. So you can capture some additional savings early in the morning prior to occupants actually occupying that space. So when we look at what a sequence would look like, and I've shown you this as it relates to both lighting and HVAC. If you're familiar with the building automation system, they live in kind of two states, occupied state and unoccupied state, typically. So this is saying occupied, 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 unoccupied. What you'll notice is when we go occupied in the morning, the override switch currently is off, and we've gone and disabled any timer values that might have occurred from the previous cycle. When we went unoccupied, you'll notice that we actually enabled the timer after hours. So that switch during the day operates like a normal switch, right? And after hours, now it is a timed override switch, because in the energy code it says if there are after hours overrides, in most cases it's limited to 2 or 4 hours depending on your particular state code. So after hours, we got to be able to provide that capability. The other thing you'll notice is that the HVAC temperature and ventilation are down here on the bottom, and as we go through the day, you can kind of see we capture the bookends here early in the morning. We capture the bookends over here at night. We lose a little bit of savings here. I got another one I'll show you here in a second, just to kind of represent what the potential is. This was focused on controlling the bookends. But as somebody came into that space, they manually turned on the lights. So it turned on the lights, and it also provided a signal to the building automation system to change what it was doing. So a lot of you probably have existing buildings. We've been talking a little bit about new buildings, but what about existing buildings? How do you apply this to existing buildings? And if you think about it, the typical scenario, or the thing I run into a lot, is you walk into a building, they don't have a lot of good as-built data. There's one breaker panel that feeds multiple offices or multiple spaces, as represented up here on this photo. And how do I deal with that? How do I control those spaces? Well, here's a couple of examples. One example is to actually just interrupt that 120 amp circuit with a relay back in the electrical closet and apply a BACnet schedule to that particular zone, turning those lights on and off based on what we just showed you, essentially. And in this case, we've dropped a telephone override unit in, or in this case, we've dropped in a local override switch. The occupants would essentially get notified by what we call a blink warning. That would allow the lights to essentially notify the occupant that the lights are going to go off in 10 or 15 minutes. That would give them time to pick up their phone and say, I need more time, or pack their bags and leave, or walk over to the override switch in this other case. But there was no recircuiting we did down here. So this line voltage switch now is basically in place. So in existing buildings, there's an awful lot of this that's possible. The energy savings on this piece is wonderful, but there are some cases where you want to actually go down to that lower level and actually take control of those spaces individually. They probably have different schedule requirements potentially. That's what would drive you in that direction. There's some other things that might drive you in that direction, which we'll get to a little bit later, but in this particular case, the only reason we're going distributed control, mounting a controller essentially in that physical space above the ceiling usually. We would now have a BACnet network go into those devices. The local schedule would be there, and then there's no need to have a separate override switch, because now the switch that was there becomes the override switch for that space because it's integrated into the controller. So how do we capture some additional savings in another area? So we're going to bump the savings up a little bit here. We're going to try and capture some savings towards the end of the day. If I take a typical classroom, there's studies out there, IES papers and stuff like that, that basically explain that there's about 2.5 hours during the normal occupied state of classrooms. I actually took the liberties and went 3 hours here, but essentially what we're talking about is grabbing savings. Now, maybe at the end of the day, maybe broken up during meetings, so you might, if you were to actually look at this as a trend chart, you might actually see a slightly different look, but for simplicity's sake and my PowerPoint skills, I went with something very simple. So in this case, what you'll see is we have very similar to what I showed you before, occupied and unoccupied states. During the occupied state, instead of messing with the timer, we actually now have an aux sensor in the space. So that aux sensor timer value has been bumped up to 30 minutes. That's a 30-minute timeout value. So how long does it wait to shut off the lights before it senses no motion, essentially? That's a parameter now that's part of the system level. It's not a hardware adjustment on the device anymore. We've essentially moved it up into the system level. And of course, that occupancy sensor now can not only trigger the lights to come on as well as let the HVAC do its thing, but as the night falls down or people leave, you can also see that come down. And then of course at night, we want to get a little more aggressive with occupancy sensors, so we throw in a little lower timer value potentially. And this can all happen automatically once you've got these two systems together. So lots of capability there. Again, when you look at it, there's an awful lot of folks out there that potentially have standalone lighting aux sensors in your space, a few of you guys. I saw a lot of hands go up earlier for facilities folks. So what you'll find is in most cases, those sensors are adjusted manually. So if there's a problem, somebody's got to get on a ladder, go adjust a dip switch or potentiometer or something along those lines. The typical complaint I hear is, got to do jumping jacks to keep my lights on. Lots of, especially higher ed folks, I hear that complaint all over the place. The other thing is that, typically when aux sensors are put into your facility, they're based on this ROI, this return on investment, this energy savings piece that they're talking about. In a lot of cases, what I find is most facilities folks don't have a good idea of how those sensors are actually performing, other than the lights are on and nobody's complaining. But are they on all the time now? Are they actually going off? When is that sensor likely to fail? When it does fail, how do I know it? So by making it part of the system, we can actually get some of this data out of it. In addition, because the aux sensor now becomes part of it, we could potentially do some other customization of control sequences, as I described a little bit earlier. So how does that happen? Well, again, we would go with distributed controls in this case. We'd plug into that existing occupancy sensor and switch and run our BACnet network to that space. And the goal here is to capture that when the space is unoccupied and the lights are on. That's kind of a before and after picture there, if you will. The other thing you got to think about is there are some additional savings potential. This is not related to energy savings, but I run into a lot of facilities folks that this is a hidden cost to them. If you don't outsource or pay people to come in and do your relamping for you, could be a hidden cost. You think about a classroom, typical classroom, 10 to 12 fixtures, 2 to 3 lamps per fixture. How many times before your facilities folks go into that space and say, maybe we should do a relamp of this entire classroom. Most people do spot relamping. That's the norm in the industry. No, not very few people do group relamping. So what happens is you pay an awful lot of labor cost. The other thing you'll notice is that as the start time or the on time of the fixture, especially with fluorescent lights, and this is a chart of instant start, rapid start, and program start, ballast, lamp life as it relates to on times per start. So if you look at this, as you would start to adjust your occupancy sensor timer value down and get more aggressive with energy savings, I typically hear complaints, oh, well, we're losing a lot more lamp life. Our lamps aren't lasting as long as they used to. That's a typical scenario. The other thing you run into is that most of the fixtures that ship out of the factory go out with an instant start ballast. It's the most energy efficient. It's the one that most people buy because it's also probably the cheapest. But what happens when you go back to an existing building and stick in occupancy sensors on a fixture that has instant start ballast? It has a dramatic impact on life. It's about half there at 15 minutes. So that's a little less than 5,000 hours, and that's about 10,000 hours. So you can see what the impact is. So as you start to unify your systems and bring it together using BACnet, what you can now do is share those data points. You can look at lamp runtime. You can look at what your timer value is and to basically start to manage that. Well, what I call equipment optimization can now be employed through this methodology. The other thing you probably hear about is level control or daylight harvesting. We're starting to see it creep into the energy codes. They don't mandate how you do it, but they're basically starting to mandate some daylight harvesting out on the West Coast, and we're seeing it move east like it normally does. So this is another area that you're going to run into, so I wanted to share a little bit on this technology with you. So there's some different ballast technologies, what I would call step ballast or step ballast technology or bi-level control. Bi-level is probably the norm. You know, a lot of people have this probably in their facility where you would have inboard and outboard, two lamps being controlled by one ballast and the inboard lamp controlled by another ballast. In that case, you would typically have 4 levels of light. You know, you have basically off, 1/3, 2/3, and 100% when both of them are on. There's also another ballast out there called a step dimming ballast that actually has basically, it's one ballast and basically replicates this where there's basically 2 switch legs going into it. So it's 2 relays essentially. I'll show you the benefit of this. You'll see it when I show you the graphic, but it has 3 light levels off, right? 50% or 100%. But there is some benefit to this. I'll show you here in a second. Both of them basically utilize 2 relays for control. And when you look at what the energy code says for light reduction controls, it says the light reduction controls has to take it down by at least 50%. So both of these would qualify for that. The other methodology for doing level control or daylight harvesting is what I would call the 0 to 10 volt dimming ballast. It's being positioned in the market by most of the ballast manufacturers as an energy management tool, not an architectural product, because most of you know if it's architectural, it's got an architectural price associated with it. So this has continuous dimming, and that range varies by the ballast and lamp type typically, but it's anywhere from 100% down to 10% or 100% down to 5%. There's even some cases where I've seen it down lower than that, 3%. You can use it on pretty much any linear or compact fluorescent, HID, or LEDs. A lot of you guys probably have seen LEDs coming out. So there's lots of different manufacturers for this ballast. And the nice thing is you have the ability now to basically do continuous dimming throughout the range. So different levels. You can come in and set max values within the system or minimum values within the system as well. So those are the kinds of things that really allow you to maybe do some load shedding or task tuning in particular applications, which you wouldn't get with the 2 previous ballast types. So when we look at this particular sequence now, this is employing the bi-level control. So you'll notice the middle lamp is out, right? So unless you've done some education with the users in that space, you may get a phone call to the maintenance department saying, hey, we got lights out. So that's one of the drawbacks of bi-level control, but you know, if people understand it and they have lived with it, it may not be that big of an issue. The next one is This is using 0 to 10 volt. You could also use the 50%. So let's say that these lights were set to 50%. All the lamps on the step dimming ballast actually go to the same level. So there's no lamps that are out in the step dimming or the 0 to 10 volt application. The net effect is if you're dimming the lights to 50% or 60% or whatever percentage that is, the savings is basically going to be the same regardless of which ballast technology you select. The issue is how does it perform in that space, and is it likely to get overridden? Because that's the one thing I see with most daylighting control or level control systems is they either don't get used or they get bypassed because the facilities guy idea of eliminating complaint is wiring nut and bypassing most of those systems, right? So if you have visibility and it's part of your infrastructure, you can see that. So when we add level control, what we're talking about is a little different, right? We have to go distributed here because if you try to do level control with all the points of wiring that you have, you try to do this back in the electrical closet, we get very expensive fast, right? So by moving the control out to the space, now we can bring in bi-level control of the switches, in either this case, the bi-level ballast or the step ballast. We have an Aux sensor in that space, and then of course we've got 2 zones for on-off control. In the 0 to 10 volt dimming ballast scenario, we have an additional wire, additional control leg, which is the 0 to 10 volt analog signal. The one thing you'll need to understand is if you try to use, say, a DDC controller to control the 0 to 10 volt ballast, that analog output that you would typically use on a DDC controller is completely different than the analog output that most lighting guys use to interface to a 0 to 10 volt control signal on a ballast. And the reason for that is the 0 to 10 volt ballast actually supplies the 0 to 10 volt signal. So your input actually has to sync current, not source current. Most of our specifications, and we're not the only one here, myself and Watchstopper have booths here. We're back to back over 518 and 418, I think it is. But the 0 to 10 volt ballast control, both of us recommend a 100 milliamp sync capability on each channel of dimming for 0 to 10 volt. As you add ballast to that network of 0 to 10 volt, it increases that current essentially. It's about 1 milliamp to 3 milliamps depending on the manufacturer and the ballast. So you can see that you can get up to 40 or 50 ballast relatively quickly on those. So that's what the adding level control is about. Any questions on that? So when we look at the daylight harvesting strategy, there's not a lot of savings here for HAC. As the sun changes, right, the light level in that space changes either darker or brighter depending on where that light is. So spaces like lobbies or classrooms or spaces where you have a significant contribution of daylight or spaces where you would want to employ a daylighting strategy. The other thing you got to think about is, even if you don't employ a daylighting strategy, there are just providing occupants with manual control will help reduce energy. What I find is a lot of spaces tend to be overlit, especially if they're older facilities. Maybe with the newer facilities or direct indirect, that's probably not the case as much anymore. But if you go to a bi-level control strategy or a dimming strategy inside of an office space or some classroom or meeting room, what you'll typically find is people will turn on one set of lights when they come into that space, or they'll get comfortable with one set of lights. A lot of spaces are overlit, and I see that quite a bit. You can walk through a lot of CAD departments or places where people do a lot of computer work, and you either see the shading around their cube or the shading over the lights to keep the light off of their workspace. So when we move to daylight harvesting, the thing that gets added is a light sensor to pick up the daylight in that space. This would be an example of what I would call closed loop control in this case, because if the light sensor is in the same space, it's reading a combination of both electric light and the daylight in that space and adjusting accordingly, whether it's bi-level, step, or 0 to 10 volt control. The advantage in this case with 0 to 10 volt control is that photocell, as it sees the change, it can happen relatively slowly, and you can make it essentially imperceptible to the occupants of that space. You're not going to affect productivity of that space. Versus in either bi-level or step technologies, there will be some form of change, instantaneous change in light levels in that space, which will be picked up by the occupant. So if they're not familiar with that, you may get some productivity hit there, or some complaints related to that. Some of that depends on your environment. There are some companies that I've talked to, I'll leave their names out of it, but there's some companies say, look, hey, if people can't work under these conditions, we're trying to save energy and we're trying to be green, but we don't want to have to pay for the advanced dimming technology. We're going to go with switching. Well, that's what we want. That's what we're going to use, and we're going to educate our people on that. There's other companies that say the 0 to 10 volt dimming is the way we're going, and they've decided to go that direction for their own reasons. So it's really a choice you have to make, but there's lots of different options there. Any questions on that? So one of the things I want to point out while we're on this particular chart is what you'll notice is that the point density in these rooms has gone up a lot when you start looking at some of the reasons why there's a trend towards distributed controls. In the past we'd stick a low voltage switch and a relay back in the electrical closet and called it good, right? Now we're dealing with sensors for light, sensors for occupancy, bi-level control or dimming control in that space, 1 or 2 relays in that space. I think about a typical classroom that I see today. In a lot of cases, there's 1 or 2 on-off zones. There's a daylighting zone. There's a teacher work light. How you have all these different things in the space now, which are driving the need to distribute the controls. So that's another reason why we're seeing that trend. So, when you look at how you can deliver energy performance in a building as it relates to lighting, clearly most of the savings is on controlling the bookends, and whether you do that with occupancy sensors or scheduling is really up to you. But that's where most of the savings is going to come from. There's some additional strategies you can employ between 6 a.m. and 6 p.m. to try and continue to foster additional savings. But we think the best bang for the buck typically is towards the bookends, manual on, and aux sensor control. Typically those are less than 3 or 4 year payback for most of those projects. Daylight harvesting, they can be a good payback depending on which dimming technology you pick. If you pick the switching technologies, they're probably going to be much faster than a dimming technology. The dimming ballasts typically add a significant cost. That cost is coming down as time advances, but it's still a fairly decent impact. It's typically 3 to 4x a standard ballast, if you will. So just look at that. Talk about 10 or 12 ballasts in a room, and you start adding up that cost. You have to get some really good savings for that to be a good payback. So if when I talk to customers and they say, I want daylight harvesting and I want a less than 4 year payback, okay, well, and I'm probably going to talk about switching technologies, not dimming technologies. So there may be other things that drive you in that direction as well, but that's kind of the general thoughts on that. So in kind of wrapping up here, and then we'll have some time for questions, I think. I would encourage you to develop your own strategies. When I work with end users or contractors or engineers, the thing I encourage you to do is develop your own energy management strategies, whether they're unified or just standalone stuff. To me, that's the key, because if you look at most buildings, some of the examples I just went over could be used in a lot of different buildings, whether it's K through 12, higher ed, hospitality, general office building environments, things along those lines. So when I look at a building, there's probably 5 to 10 lighting control strategies in most of those buildings. And there are a lot of commonality between those. And being able to basically tweak those as you go along, depending on the application, is key. As you develop your strategies, the next thing you need to start thinking about is making sure that you put it on a platform that's going to be sustainable for you. So picking the best of breed BACnet products to do that is key. Of course, implement, which is typically the hardest step, getting the funding, nailing down the payback, those kind of things, right? But implement. Once you do implement, make sure you measure and verify performance. To me, that's key. You can't Energy started a study, right? It's the same study you guys probably heard on the HVAC side. But if you have technology in your building, that doesn't necessarily solve your problem. You have to be able to maintain that system throughout the life cycle of that building. So measure and verify performance is key, and then of course continue to refine. So that's kind of my parting thoughts. So I'll open up for questions. Any questions?
I know kind of the point of, a big thing you stressed is this whole weakness back. Where is Dolly's place?
That's a very good question. So his question was about Dolly. Dolly is a digital addressable light interface. That's what DALI stands for. It is a ballast protocol, primarily developed in Europe and brought to the States about 10 years ago. I'm going to give you my personal opinion on the Dolly stuff. We, as a manufacturer, have looked at Dolly, and there's two drawbacks that right now I see in Dolly. One is it doesn't have collision detection or collision avoidance in the open protocol standard for Dolly. And we see, unfortunately, too many manufacturers here in the U.S. employing controls on the same network as the ballasts, which can create a lot of conflicts and issues. So addressable, so I'm going to segue from Dolly to addressable ballast technology a little bit, because I think there is a space in the market for addressable ballast technologies, but I don't know that it's an everyday solution for most people, because it's primarily driven off of the reconfiguration of that space, or being able to easily reconfigure that space. But there's an awful lot of infrastructure cost that goes with delivering a addressable ballast solution. Each of those ballasts has to have an address. Somebody has to make that happen. That ballast address and information has to be maintained throughout the life cycle of the building, and where does that get maintained? In addition to that, you have some connectivity issues potentially between the building automation infrastructure connected to Dolly all the way down to, say, the user level at the cube space. How do I control the fixture above my cube, and how do I maintain the relationship of that throughout the life cycle of the building? When that ballast goes bad in the Dolly world, or how do you replace, who's going to replace that ballast and make sure it gets the right address and the right programming back in so it can go back into the system. So I see a lot of, this is not saying bad things about facilities people, but I see facilities folks have a lot of difficulty maintaining what I already sell them, let alone something that's 10 or 5 times more advanced than centralized or distributed type controls. And in my opinion, I don't think you get a lot more energy savings out of addressable ballast technology. You can get some targeted things, but I'm not sure that the payback is there for most customers that I've talked to anyway. So I don't know if that answered your question or not, but.
Let me add a couple more things about Dolly. At this point, Dolly is pretty much the only protocol at the ballast level that you can co-locate the network wire with the high voltage wire to the ballast.
Right.
One of the advantages of Dolly is that you can get kW for each fixture now. So you know exactly the very, very fine data, granular data on the fixture. It will help in the long term with demand control. It also gives you information on the fault related to the fixture. We get faults on all sorts of pieces of equipment, and Dolly will give you that information. One of the considerations you have to appreciate is that there is vanilla Dolly, okay, where based on the standard, but there are manufacturers, for good reasons, have extended Dolly.
Right.
So it's an upgraded version of Dolly. So if you have a manufacturer with that technology, and we put systems in like that, okay, you have to realize that you must buy the ballast from that manufacturer. So it is not it's pitched as an interoperable standard if it's vanilla version Dolly.
Right. Great. Good comments. In the back?
How's the reliability of the components that are made, the light sensors, all the other things? Because what I would want to get into is where now I've got 20 things to troubleshoot instead of 2.
Yep.
Looking at automated systems.
Well, at least in the world that I live in, my system doesn't care what sensor you use. You can use anybody's sensor.
But are any of them very highly reliable for the long term?
Yes, I mean the Aux sensors have been out there for a number of years. They're pretty proven. they weren't before, right, or in the early days, but I believe they are now. Same thing with light sensors. The issue typically that I see with any given application is how does that system get programmed and checked out and turned over to the owner. That's typically where most things fall down. I've been in the lighting control industry a long time, and I've seen the differences between what we normally see on the mechanical side of the business as it relates to controls, written control sequences, points lists, checkouts, all that stuff is in a mechanical control specification. When you look at lighting controls, it's all product feature driven stuff, right? It's the can shall be metal. And a lot of those things are important, but there's no control sequences. There's no points lists. There's no checkout procedure in there. And to me, that's what we're trying to do. By leveraging the controls contractor that's already in the market, the best guy in the building to do this work that's already doing it on the mechanical controls, there's no reason he can't apply those same methodologies to the lighting controls. So.
You talked about lights, interior lighting largely. Can you touch on high bay lighting and exterior lighting, and what you may offer, how your system works with other areas of lighting?
Yep. As it relates to high bay or exterior lighting, things along those lines, typically there are other manufacturers that make BACnet products other than us. Check them out, please. I'm not here to tout what I offer, but what I typically see when you look at, say, an indoor warehouse application is what you'll find is it's a row of fixtures. That row of fixtures is fully loaded, typically to 20 or 30 amps. In a lot of those cases, most of those solutions have been breaker-based control, something like the Square D PowerLink or the Cutler Hammer PowerR command style products, right? Those are the kinds of products that we typically see there because the circuit's fully loaded, you're fully utilizing not only the circuit protection function, but the control function, and there's a single point of termination for the electrical versus a separate relay panel, where the relay panels have typically some other benefit when you get down into smaller zone control, right? If I got a 20 amp circuit feeding multiple areas, I can break those up on separate relays, which you start to have some diminishing return when you try to do that with, say, breaker control, if you're familiar with that technology. Outdoor lighting control, man, it's a wild west right now. There's a lot of stuff going on with outdoor lighting control, especially with wireless technologies and things like that. So we don't participate in that particular portion of the market directly, but indirectly, when we control a building, we'll control some exterior lights. But typically, those are areas that you're starting to see more and more demand for wireless controls. And the ability to actually treat the fixtures or control them individually so that at night you can essentially take, say a pole's got 4 lights on it, you can have the ability now to essentially only have one of those lights on tonight, the next night you rotate it to the next one, the next night you rotate it to the next fixture, next night you rotate it to the other fixture. So after hours now you can still maintain good light levels and improve your life cycle performance rather than just keeping that one light lit all the time at night. So lots of different capabilities there. I think we got time for one more question if there is any. Otherwise, thank you. Appreciate your time.